we will understand about dead load and live loads. A building has to perform many functions satisfactorily. Amongst these functions are the utility of the building for its intended use, that is occupancy, structural safety, fire safety and compliance with hygiene, ventilation and daylight standards. The design of the building is dependent upon the minimum requirements prescribed for each type of these functions. Now, let's focus on the structural safety of the building. It is governed by various design loads to which the building is exposed or likely to be exposed. Various types of design loads which are to be considered are dead load, imposed load, also referred as live load, wind load, snow load and seismic load. Before we understand the various type of design loads in detail, let's briefly understand various types of design load with help of this slide. Dead load is due to the self weight of the structure, whereas the live load is due to occupation or usage of the building. Snow load is created by the snowfall accumulated on the surface of the building. Seismic load is created due to the earthquake, and wind load due to the wind pressure on the surfaces of the building. Now coming to the dead load. Dead load in any building is due to weight of all the elements inside the structure. These will include the weight of all components at each level, like roof including water tanks, parapets, roof finishes, slabs, beams, elevator machine, etc. Therefore, it is the permanent load and it always acts vertically downwards. It also remains constant over time. The dead loads are calculated from the estimated material densities and member sizes. The unit weights can be taken from IS 875 Part 1 or ascertained from the manufacturer. Unit weight is then converted into uniformly distributed load as in case of beam and slabs, or concentrated loads in case of columns. These loads, being permanent, are combined with different loads to arrive at the most critical load combination for design. Next is imposed load, also referred as live load. Live loads are created due to usage of the building. It consists of moving or static loads of persons, machinery under motion, etc., and may have impact momentum or vibration. It is a non-permanent load and varies over time. Live loads prescribed by codes are conservative and empirical, based on experience and accepted practice. IS 875 Part 2 deals with the imposed loads on roofs, floors, stairs, balconies, etc. for various occupancies. It has a major role in design of building, especially in case of dynamic load. There is a provision for reduction in the imposed loads for certain situations. Example, for the large span beams and number of story above the columns of a story. The earthquake code IS 1893 permits general reduction in roof and floor imposed load when considering the load combination with the earthquake loading. Also, impact load is caused by vibration or impact or acceleration. A person walking produces a live load, but soldiers marching or frames supporting lifts and hoists produce impact loads. Thus, impact load is equal to imposed load incremented by some percentage depending on the intensity of impact. Now, let's recap the salient differences between dead load and live load. Dead load is permanent, whereas live load is imposed only during usage. Dead load can be planned or designed only during construction stages, whereas live load can change anytime throughout the lifespan of the structure. Impact of dead load is fairly constant and known, whereas live load is varying and is relatively difficult to assess, especially in cases of dynamic loads like machines, cranes, etc. Ladies and gentlemen, with this we have come to the end of this video. Thanks. Jai Hind.